It's 12:01 now, so
this meeting is being recorded.
Excellent. Well, good afternoon, everybody. Thank you so much for joining us today, and welcome to our webinar. My name, Gianpaolo Versace, account executive at Chase Office Interiors. Really enjoy having you today and join us for our webinar. Today's topic will be acoustics, the key to happier and healthier workplaces. This is a CEU accredited presentation, and if you have sent us your IDCEC registration number, we will process that and you will see the credit appear probably in the next 5 business days. We know that's important. Our presentation today usually take 45 minutes, but our guest speaker asked for a few more minutes. So we're pushing it to 50 minutes. And then, of course, we will have some time afterwards to answer some questions. Feel free to put those in the chat while the presentation is underway. So we'll capture those at the end. We are recording this webinar and will be made available on our website, chaseoffice.ca/events. We'll do that in the next 72 hours. Also, just looking forward to next month. So please register for our next webinar called Healthy Materials on May 12th. So let me now start introducing our guest speaker all the way from the United Kingdom, Manchester area, I recall, Richard Ellerbeck. Richard has a major in psychology and a minor in sound technology from the Rhodes University in South Africa. He worked as an acoustic consultant for 7 years with a focus on improving acoustics in a variety of corporate and office settings. And then after that, he joined Buzzi Space, where he's worked now for the past 3 years. He's an accredited speaker for both CEU and CPD programs, helping designers, architects, and facility managers gain knowledge about the importance of acoustics during the kickoff for strategic projects. So thank you so much, Richard. This is your show, so we're moving over to you. And please start sharing your screen with your presentation.
Terrific. Thanks for that, Gianpaolo. I'm thinking I should have you do the introduction before any presentation I give.
Well, I'm sure that a fee can be arranged for that.
Right, folks. Okay, so as Gianpaolo said, the presentation is going to be about 50 minutes. It's actually normally 1 hour, but I'll try and be slightly more concise in certain areas. As Gianpaolo said, if you've got any questions, you can put them in the chat box, or you can save them to the end of the presentation where you can put them to me verbally. Now, just in terms of the content that we're going to go over, acoustics is a very broad topic. The focus of the CEU in terms of the intended audience was really was created for specifiers, architects, and interior designers. Because it's a CEU framework, we're not going to be mentioning any of the products by name. Anything that you do see is obviously a part of our catalog, but obviously in keeping with it being an educational framework, it's not just going to be about the products or the solutions. We're really going to be taking a slightly broader look at things, and particularly focusing on workspaces in particular and how acoustics ties into that. So just a quick run over in terms of the content. We'll start off with why acoustics matters. So what is the inherent value proposition? What are we actually trying to achieve? Second section, understanding sound. What is it? How do we measure it? How do we quantify it? Third section, reverberation. That's probably one of the most important parameters when it comes to managing noise levels and improving call quality. Fourth section, that's a little bit more practical in its approach, kind of just delineating different types of acoustic issues that you can encounter and which product categories are well suited to solving those types of issues. And then the last section, acoustic data. So how do we measure the performance of acoustic products? How is that information and that data displayed? And what are a couple of things that you need to bear in mind when you're looking at making comparisons between different products and different suppliers? Right, so as a starting point, I always think it's fitting to look at the definition of acoustics. So we define acoustics as the properties and or qualities of a building or room that determine how sound is transmitted in it. So when you say acoustics, people think of sound. It's got a lot to do with sound, but really the acoustic quality of any space is determined by the architecture and the types of furnishings that you actually have in that space. So every single physical object is going to interact with sound waves in one way or another. The more hard and dense the material is, the more likely it is to reflect sound waves, things like glass, concrete, gypsum board, timber. And then on the other end of the spectrum, your soft, porous, fibrous, and breathable materials are actually able to absorb sound. And that's really not limited to acoustic products per se. You get lots of materials, carpet, curtaining, drapery, any kind of textiles, soft seating, all those types of products or elements that are made out of porous or breathable material are actually able to absorb sound waves to a certain degree. But when we look at what we're actually trying to achieve, and I suppose this is actually conveyed in the title when we talk about creating happy and healthy workspaces, that's exactly what we aim to achieve when we talk about having a good acoustic design in an office space. It has a fundamental impact on people's well-being as well as their productivity. There's a lot of synergy between those two things. They often go hand in hand. I think everyone is familiar with how stressful a noisy environment can be. But when we look at workspaces in particular, there we obviously want people to be as productive as possible. People are very familiar with ergonomics, the importance of having a good workstation, appropriate seating. We obviously understand the benefit of having good, adequate lighting in a space, and people also know the importance of having good light, not just good lighting, but also good ventilation. So light and air, those are two environmental factors that have received a lot of attention. It's really probably only over the past 10 or 15 years that sound and acoustics has started to receive the same attention. And a lot of that coincides with the shift in the workspace. A lot of people are doing more activity-based work. People are favoring a more open plan setting to their offices. That can obviously enhance and promote collaboration and interaction. But along with that, you obviously experience an increase in noise levels. So it becomes harder for people to actually concentrate. Now, we talk a lot about noise and the connection between reverberation and noise, but it's very important for us also to make the distinction between conversational distractions and background noise. So this particular quote is drawn from a very renowned acoustician. His name's Julian Treasure. You can actually find him on YouTube. He's done a very interesting TED talk for architects. It's only about 12 or 15 minutes long, but it's a very interesting watch. Now, he cites that employees can be up to 66% less productive when exposed to just one nearby conversation. And that's really not a fact that he's just plucked out of the thin air. There's lots of surveys and studies that have been done looking at workplace distractions, things that impact people's productivity. All of them across the board really highlight conversational distractions as being the biggest impact. The reason for that being your brain, from a linguistic and an evolutionary perspective, your brain is hardwired to pay attention to human speech. So just like a computer, our brains process a lot of incoming information. We need to sort, categorize, and make sense of that information in order to determine how we react with our environment. So your brain isn't capable of receiving all of the sensory information and pushing all of it into your field of awareness. It has to be rather selective in terms of which pieces of information from your senses and from your environment are most relevant and most important. So bearing in mind that we are fundamentally social beings, civilization and our entire society is predicated on our ability to communicate, speech and conversation is automatically very highly prioritized. It would almost be appropriate to say that people are hardwired to eavesdrop on conversations. So it doesn't matter what you're doing, if you're sat doing any kind of task, the moment a conversation starts up, the moment you can make out the words and sentences of what's being said, that's the point at which you start to operate at a cognitive deficit, because your brain is pushing that conversation into your field of awareness. And really, that's the point at which you're having to split your cognitive resources. You're having to consciously block out that conversation while trying to continue with whatever task it is that you have at hand. We see a lot of people nowadays in open plan offices with earphones in their ears. There was one study we came across a while ago. It was quite interesting. It actually alluded to the fact that a lot of people aren't even listening to music. They've just got the earphones in to block out any conversation and to signal to other people that they're trying to focus. When we look at it a little bit more broadly, I won't mention all of these points. Sound and noise affects you physically, it affects you mentally. When you're exposed to increased noise levels, generally what happens is your heart rate starts to increase, your blood pressure goes up. Once those two biological markers are on the rise, your body actually starts to produce more cortisol. And even though cortisol is a very important hormone in terms of regulating our circadian rhythms throughout the day, if you have too much cortisol, particularly over a prolonged period of time, it's going to leave you feeling very fatigued, and it's going to impact your ability to actually be able to focus and concentrate. So when we look at sound in particular, what is it? Just like light, just like heat, it is effectively a form of energy. And we characterize that energy as vibrations that can be carried through a variety of different mediums. We experience them as airborne vibrations. And just like we can't see ultraviolet light, we can't see infrared, there's a very limited range in terms of the sound waves that we're actually able to perceive. And that's from about 20 all the way up to 20,000 hertz. Now, the main way in which we categorize sound waves is to refer to their frequency. So when we talk about the frequency of a sound wave, we are referring to the number of vibrations that a sound wave has in a single cycle. So one cycle is always measured as 1 second in duration. Here you can see we have a sound wave that has 1, 2, 3, 4, 5 vibrations in a 1 second cycle. That's what gives it a frequency of 5 hertz. Now, the reason it's so important that we are cognizant and mindful of the different frequencies is because no acoustic material or product will provide the same degree of absorption across different frequencies. When you look at your high frequencies, and that's anything we would really classify as 2,500 hertz and upwards, your higher frequencies have a much shorter wavelength. That makes them a lot easier to absorb. Things like drapery, even simple carpet tiles are generally sufficient in terms of absorbing high frequency sound waves. As you start to lower the frequency, the wavelength starts to increase. That makes it harder to actually be able to absorb those sound waves. So when you're looking at acoustic materials, the two most fundamental properties of that material that are going to determine how well it is able to absorb sound is the density of the material and the overall thickness. I cannot stress enough how important it is to try and use acoustic materials that are of an appropriate thickness. We normally suggest, where possible, using products that are 2.5 centimeters or thicker. I'm just trying to work out in my head. I think that's something more or less around 1 inch. The thicker the material is, the better absorption you're going to get, particularly on your mid frequencies and your low frequencies as well. Generally, in most workspaces, the majority of the noise that you're going to encounter is going to be from people who are talking and communicating. So the most fundamental frequency range to target is really the speech frequency range. That's from about 250 to 2,500 hertz. It does extend a bit beyond that, but the majority of human speech is going to occur somewhere in that frequency range. So when you're looking at acoustically treating a space, it makes sense to use materials and use products that are well suited to absorbing on that particular frequency range. When we look at the density of the material, there you do end up dealing with a bit of a trade-off. If you have a lower density material, it'll generally absorb better on the higher frequencies. If you have a higher density material, it'll absorb better on the low frequencies, but it'll actually start to reflect the high frequencies. So a lot of the time you want to try and find a material that's a little bit in the middle ground, that's able to give you relatively good absorption, particularly across the speech frequency range. I will just mention imparting these three icons. If you ever go through any of our product literature, you'll see these three icons next to the products. That's just to indicate which particular frequency range that item is well suited to absorb at. Right, then one fundamental distinction that we always need to make is the difference between building acoustics and room acoustics. So when you're dealing with the transmission of sound from one space to another, that can be from outside to inside or even between two adjacent rooms, that is what we refer to as a building acoustic issue. And the reason we use that terminology is because it is a structural problem. It's got to do with the types of materials that you're partitioning and your ceiling and your walls are actually made of. A lot of people have the assumption that the sound is actually traveling through the wall. 98% of the time, that's not the case. Sound is going to behave very much like water. It'll take the path of least resistance. If you imagine you had a fish tank with very thick glass walls, if you've got a crack or you've got a gap somewhere, the water will leak out. And it's exactly the same with the sound. We see this quite often in offices where you've got drywall partitioning, particularly where you've got a dropped suspended ceiling grid. A lot of the time your partitioning is not taken all the way up to the concrete soffit. So especially if you've got a ceiling grid with acoustic ceiling tiles, some tiles work better than others. But remember, in order for something to absorb sound, it needs to be partially porous. And that means some of the sound is actually able to pass through. So a lot of the time we find that the passage of sound is actually through the joins of the walls, if those aren't airtight, and also potentially any gaps above the partitioning itself. It's essentially a soundproofing issue. It can be very difficult to resolve. The most effective solution, which often isn't practically feasible, is simply to have your partitioning go all the way up to the concrete soffit, ensuring that you have one solid, unobstructed barrier between the two spaces. Very important to understand, putting sound absorption products in one or both of the rooms is not necessarily going to reduce the amount of sound transmission between there. If both of the rooms are highly reverberant and they've got very high noise levels, if you put absorption into those rooms, it can reduce the reverberation, that can reduce the noise level, and that can have some impact on the amount of sound transmission between the two spaces, but conceptually, it's not generally the correct approach to go. And like I said, it's a structural issue. What we deal with in particular is room acoustics. So we are concerned with sound that is produced within the room and how the architecture and the furnishings in that room are causing that sound to behave. That's really the domain in which sound absorption is most relevant in terms of the benefit that you can accrue from those items. So in summary, when we're talking about reverberation in particular, it would be appropriate to say that good acoustics is all about balance. The amount of reverberation you have in a space is going to be a factor of the size of that space and also the architectural finishes that you have in there. So generally, the larger, the more reflective a space is, the more absorption you're going to need in order to balance out those scales. So a lot of what you need to end up doing is there's certain calculations that can be done for spaces. We actually have a very useful RT60 app. It's free to download on the Apple Store. You can just search Buzzi space RT60 app. That'll allow you to actually measure the reverberation time in a space. Once we've done that, we're able to determine how much absorption we need to add into the space. For that, we use a unit of measurement called sabins. Sabin is effectively 1 square meter of 100% absorption. So once you know how many sabins you need to introduce into a space, then it's really a process of identifying in what shape and in what form are you going to introduce that material into the room. Is it going to be wall mounted? Is it going to be ceiling suspended? Is there perhaps a need for functional acoustic solutions, things like acoustic lighting or even acoustic furniture? And then lastly, the placement of your acoustic material. can have a big impact on the performance. Earlier I said it's the thickness and the density of your material that determines how well it absorbs sound. That's really only partially true. How you introduce that material into the space will have a significant impact on its performance. People always ask us where should they put their absorption. Fortunately, that's quite an easy question to answer. Ideally, you want your absorption as close as possible to the source of the sound. Generally, that's going to be people who are actually in the space. So when we look at reverberation, that's effectively referring to the phenomenon of sound waves reflecting off hard surfaces in a space. This little diagram we have is only partially accurate. Sound waves travel in a straight line, but they're also omnidirectional. If you had to imagine yourself blowing up a balloon, as you inflate the balloon, it expands outwards in every single direction at once. That's exactly what's happening with sound waves. They're traveling in a straight line, but they're moving outwards in every single direction, and they move incredibly fast at about 343 meters per second. So just alluding to the previous point I made regarding placement, if you had to imagine you had a 1 square meter acoustic panel on the wall over here, that panel will only absorb the sound waves that actually reach it. Sometimes people seem to have a funny understanding of acoustics. The products are not a vacuum. They do not suck or attract the sound waves towards them. So if you had to imagine you had that 1 square meter panel over there, if we took it off the wall and we moved it much closer to the person till it was right in front of them, as would be the case if you had an acoustic desk-based screen, means that that panel's proximity is able to absorb a lot more of that acoustic energy before it is able to spread and propagate throughout the space. So really the proximity of your acoustic elements to people in the space is very important in terms of how well they're going to perform and function. Now, when we look at measuring reverberation in a space, we refer to the reverberation time. That's essentially a metric that measures how long it takes for sound waves to drop in volume by 60 decibels. The larger your space is, the more reflective it is, the longer those sound waves will persist in that space, the longer your reverberation time will be. So as I mentioned earlier, the primary influences that are going to determine how long your reverberation time is the volumetric size of the space. As the space gets bigger and bigger, sound waves have a longer distance to travel. That's why you can hear a noticeable reverberation when you're in a gymnasium, when you're in a hall. An excellent example would be an underground parking lot. That's quite a large cavernous space. It's also made entirely out of concrete, which is a very reflective material. Room temperature, that does play a role, but it's extremely marginal, so much so we don't really need to quantify it. But lastly, and still very importantly, is the absorption coefficient for materials, objects, and people in a space. So your absorption coefficient is essentially the technical term to describe how much absorption a material, an object, or even a person's body is able to offer. And as I mentioned earlier, with regards to the frequencies, the amount of absorption that you get will vary from frequency to frequency, depending on the material composition, its density, and its overall thickness, as well as its positioning in a space. Right, so just to kind of illustrate things with an example, thankfully this is not an actual meeting room, it's just a model that we created for the purpose of the CEU. This is a meeting room that would be entirely reflective. The floors, wall, and the ceiling are all made out of concrete. And then obviously you've got a fourth wall, which you can see as glass partitioning. So as it stands, next to no absorption present in the space. The only item that would provide a modicum of absorption would be the soft seating. And that's assuming that it's made out of foam and you've got a breathable fabric that it's actually upholstered in. So when we model this particular space to determine its reverberation time, generally that information is shown graphically. So you'll always have your frequencies on the x-axis from low to high. And each of these points is an indication of how long sound waves will reverberate in this given room at each of the different frequencies. So bearing in mind, these values are measured in seconds. Your reverberation time is always measured in seconds. So part of what we've done is we've managed to create an auralization for the space. That's effectively where you are able to simulate through computer software how audio or speech will sound in a given space when it has this level of reverberation. So I'll just play you a sound clip of what it would sound like presently, and then we'll show you an example of how you could treat the space and what the end result would be in terms of improving the speech clarity.
Contrary to popular belief, acoustic solutions don't have to look ugly, and we have over 14 years of experience to prove.
Okay, so you would have
Contrary
heard
to popular belief,
very reverberant. It almost makes the space sound like it's much larger than it is. When you've got too much reverberation, it can profoundly affect the speech intelligibility. So much so, a lot of meeting rooms and boardrooms actually require acoustic treatment. Clients and customers invest a lot of money in terms of the audiovisual equipment that they put in the space. These areas are often designed for functionality and visual aesthetic. So what do we need out of the space? What type of furniture? What type of technology? And then secondly, what's going to look good? What is the type of brand image that the company is looking for? And often when you focus purely on those two aspects, you're not conscious of the acoustics. It means you end up with a lot of hard reflective building materials. So you'll see over here, we've spread the absorption evenly throughout the space. That's always advisable if you can do a combination of wall and ceiling mounted elements. We've got a few freestanding seating ottomans, and then also some suspended items. So we keep adding elements into the space until we reach the target reverberation time, which will also be determined by the intended function of the room and the size of the room. So for this particular example, in order to have good call quality, good speech intelligibility, we need to have a target reverb time of 0.6 to 0.8. So after we've added a sufficient amount of absorption into the space, this is essentially what the same sound clip would sound like.
contrary to popular belief, acoustic solutions don't have to look ugly, and we have over 14 years of experience.
I won't play all of it, but you can hear it's much, much clearer. It sounds like the speaker is actually closer to the microphone, and they're just that much more audible. When you consider that meeting rooms and conference rooms with teleconferencing setups are intended as communication hubs, it's very easy to understand how the acoustics are incredibly important in terms of ensuring that you can actually use that room for its intended purpose. Now, there are a couple of guidelines that we've drawn from the Well Building Institute. These are recommended reverberation times for different types of spaces. You'll notice that these recommendations always fall within a range. It's never a single fixed figure. So for call centers, open office, 0.4 to 0.9 seconds. The reason it falls in a range like that is because it is also dependent on the size of the space. If you've got a much larger office, you can make do with a reverberation time closer to 0.9 seconds. If that space is much smaller, then you need to aim for a much lower reverberation time in order to ensure that you don't have excessive noise levels. Other considerations are obviously what is the room actually going to be used for? Boardrooms, meeting rooms, there you want to have a low reverb time to ensure the good call quality. Other spaces, corridors and lobbies, and those are transitional spaces. So generally it's not too important to acoustically treat those spaces. Other areas like cafeteria, that's more of a social setting. It's not a functional workspace. So you wouldn't necessarily ascribe that the highest level of priority in terms of acoustic treatment. Obviously, treating a space requires material. There is a cost factor that's associated with that, and budget, as is often the case, is one of the primary limitations on any given project. So a lot of the time you want to prioritize which types of spaces is it most important and most critical that we have good acoustic qualities. And as I said, that will generally be any teleconferencing setups or your general open office space as well. Right, so in terms of tackling and reducing reverberation, there are a couple of acoustic principles that we can use. The first one is the primary and most important one, which is absorption. So bearing in mind that acoustics is a branch of physics, it's governed by the laws of physics. And one of the most fundamental laws of thermodynamics is that you cannot create energy out of nothing, and you cannot destroy energy. So bearing in mind that the sound waves are effectively a form of acoustic energy, the only way for us to rapidly reduce or accelerate the reduction in that energy is for us to convert it from one form of energy to another. And that's effectively what the process of absorption is. It's a process of energy conversion. So generally what happens is your sound waves will impact upon the acoustic material. They will soak in and saturate that material, depending on how breathable and porous it is. And the general characteristic of that material, whether it's mineral, rock wool, polyester, felt, we use high density foam as well, you'll generally have a whole load of filaments of material that are quite fibrous, and they're often interconnected. So once the sound waves impact upon that material, it actually causes those fibers to vibrate. That vibration causes friction, and friction produces heat. So if you actually had a very sensitive temperature probe, you'd be able to see that the products are producing a microscopic amount of heat. And that is effectively a byproduct of that energy conversion. Now, the second principle, attenuation, that's the technical term used to describe how well a material or an object is able to block sound. So right at the beginning of the presentation, I mentioned, the importance of managing conversational distractions. How do we do that? We do that by improving speech privacy. And one of the most fundamental principles that we need to employ in order to improve speech privacy is the principle of attenuation. We want to be able to limit and reduce the transmission of sound. That can be from one workstation to another. It can even be from one part of an office to another part of the office. The most effective way to do that is with a solid wall that's floor to ceiling. But obviously, as I said earlier, the majority of people are quite attached to an open plan layout. So we have to be a little bit more creative and intelligent in terms of how we can manage that. Acoustic screening, partitioning, acoustic booths in particular are excellent examples of products that are designed to work on the principle of attenuation. It's not just about absorbing the reverberated sound, it's about reducing the direct sound transmission between occupants in a space. The last one, diffusion, that's really of secondary benefit. Even objects that are not absorbing sound, if they're multifaceted, if they're not perfectly flat, this is a little wooden puzzle I have. It's actually an excellent example of that. You'll see it's got multiple different planes. So the idea is that any three-dimensional object, whether it's absorbent or reflective, sound waves that impact upon that material, any sound waves that are reflected off it are diffused and deflected in a multitude of different directions. And that's one way to also reduce acoustic energy. Good example of that would be if you move into a new house, when the space is empty, you can hear a bit of reverb. Once you've moved all your furniture in there, even if that furniture is hard, reflective materials, you'll notice that the reverberation has lessened or gone away. And that's purely just because the objects that you've introduced into the space are creating a certain degree of sound diffusion. Right, so multiple different ways to acoustically treat a space. If it's a meeting room or a boardroom, that's much, much easier. You're dealing with a fully enclosed space. It's much easier to model. It's much easier to measure. As I mentioned, we do have our mobile app that's very well suited to testing these kinds of spaces. Just about putting the right amount of absorption in, whether it's on the walls, the ceiling, freestanding. Here we've got some acoustic lighting, some acoustic seating, some biophilic acoustic elements as well. Yes, it's a sound absorbent pot plant, and then a few other biophilic elements on the wall as well. These interestingly are made out of petrified reindeer moss. So lots of different ways, different types of materials. Obviously, when you introduce anything into a space, it is going to have an impact on the design, the decor, the overall aesthetic of the space. Given that the majority of these projects are handled by architects and interior designers, the specifiers, makes a lot of sense to try and have a broad product catalog that's able to appeal to different tastes and different types of spaces. Right, so just keeping an eye on the time, we're not doing too bad. In terms of identifying different types of acoustic issues, so these are not mutually exclusive. A lot of the time you'll be dealing with 2 or potentially all 3 of these issues. We thought we'd kind of just separate them a little bit so we can expand upon the nature of the problem, and that in turn will lead to what the most appropriate solution is. Right, so in terms of managing noise levels, we measure noise just like sound. We measure that in decibels. Decibels are actually measured on a logarithmic scale. So what that means is an increase of 10 decibels is essentially a doubling of that acoustic energy. So it'd be appropriate to say that 40 decibels is twice as loud as 30 decibels. 20 decibels is half as loud as 30 decibels. When we talk about the perception of sound, it becomes slightly more complicated. Obviously, our perception is a very subjective thing. So there are a couple of different ways of quantifying that. But when we're looking at it purely analytically, an increase of 10 decibels is a doubling of the acoustic energy. Now, part of what we want to do in terms of managing those noise levels is really to ensure that they do not exceed a critical threshold. A lot of the literature that you'll find online will tell you that a good office should be between 40 and 50 decibels. While I definitely agree with that, in practicality, it's generally not really achievable, especially with the amount of people that we see crammed into an open plan office. A little bit more of a realistic aim would be somewhere between 50 and 60 decibels. You don't want your office to be too quiet. The quieter the office is, the less speech privacy that you're going to have, the more likely you are to have conversational distractions. Classic example is a library. It's so quiet that if anyone's having a conversation, even if they're on the other side of the room, you're still able to hear them. So we do want a certain amount of sound in the space. It'll reduce the likelihood of conversational distractions. It will give you a bit more speech privacy. It's also good in terms of keeping people alert and awake. Obviously, introverts and extroverts have different degrees or levels of environmental stimulation that they want, but 50 to 60 decibels is generally quite a good compromise in terms of making sure the office isn't too noisy, but it's also not too quiet at the same time. Right, so the moment, and this is really just our advice from our side in terms of our experience, the moment your noise levels start to consistently exceed 65 decibels, that's really when we would say you could consider that you have a noisy office. It can be difficult to quantify. Noise will vary in different parts of the office at different times of day, depending on the occupancy levels and also depending who's in the office. Some people are louder than others. If your noise is consistently exceeding 65 decibels, that's the point at which you start running the risk of the Lombard effect coming into play. So that's essentially the unconscious tendency of people to speak louder in noisy environments. It's more commonly known by the colloquial term as of the cocktail effect. So it's essentially something that you would encounter at cocktail parties. So any social venue where you've got a lot of people, the noise levels start to climb exponentially. So once your noise is above 65, that's the point at which generally you need to talk louder. If you start talking louder, then the people adjacent to you, they need to talk louder in order to hear each other. The people adjacent to them need to talk louder. And you end up with a cascading chain of events where your noise levels can rise very quickly and very exponentially in a space. So we want to keep the noise levels below 65 so we can avoid the Lombard effect. If we can do that, keep it quiet enough that people don't need to raise their voice, you're not going to end up with a runaway situation. So two of the main ways in which we do that. First is obviously to ensure that we don't have too much reverberation in the space. That's really a factor of introducing enough absorption in there. but then also, quite importantly, your acoustic zoning, and that has a lot to do with your space planning. How do you lay your office out, and also looking for opportunities in which you can create collaborative and breakout spaces that are going to allow you to displace those conversations and those interactions to other parts of the office where they're less likely to actually distract people. All right, then the second one, speech privacy. So we're not referring to people's inherent need for privacy. When we talk about speech privacy, we are referring to it as the solution to conversational distractions. So generally, a lot of people are aware of reverberation. We often see panels on the walls, the ceiling. This office is a good example of that. You can see there's some paneling on the ceiling over there. So obviously they had some forethought regarding the effect of reverberation in the space. But a lot of time people completely overlook how significant an impact direct speech transmission can have. The shortest distance for sound to travel between two people is in a straight line. So if you've got a clear line of sight between people, you're going to have a high degree of direct sound transmission. And those sound waves are going to carry the most significant amount of acoustic energy. So it's really generally not sufficient just to put panels on the walls and the ceiling, just to focus on reducing the reverberation. Yes, that will manage the noise levels, but if we really want to improve people's productivity, it's a process of reducing distractions in the office space, speech in particular. So that's really where your acoustic screening and your partitioning comes into play. In my personal opinion, desk-based acoustic screening offers some of the best value for money. You've got your absorption in the space. You've got it as close as you can get to the particular person. If you use a good desking solution, generally that should be a screen that has what we would call a composite substrate. So it's got a variety of different materials in it. Remember, your acoustic material, it's porous, it's breathable. That means it's not good at blocking sound waves. When it comes to a desk-based screen, we really want the best of both worlds. We don't want the screen to be reflecting sound. We want it to be absorbing sound, but we also don't want it to be leaking sound through. So we want it to absorb and we want it to block sound waves. In order to do that, we need to use materials that are diametrically on opposite ends of the spectrum. So in our particular case, we use honeycomb cardboard as a central core. That's obviously a more dense, non-porous material. And then we use felt or high density foam on either side of that inner core. So two different types of materials, giving you sound blocking, but also giving you sound absorption. The other benefit to be mindful of, we're talking about productivity. That's not just about tools. As I said, it's about reducing distractions. Sound is one of the primary distractions. But people are also exposed to a lot of visual distractions. At the end of the day, we are still inherently, I was going to say creatures, but we are inherently animals. If you are sat in a space and you pick up any kind of movement in your peripheral vision, unless you're extremely well trained, generally the instinctual thing to do is to look up to see what it is. So being mindful of the amount of foot traffic and physical movement you have in an office space, having a good degree of acoustic screening can block out some of the sound, but it can also reduce visual distractions as well. We normally advise people to try and go for a screen height of about 60 centimeters from tabletop. Generally, that's high enough that you've got coverage above the mouth line, but it's not so high that people can't actually peek over the top. You need to find a healthy compromise and a balance between the two. We know people don't want to go back to being stuck in a cubicle, but if you're going to go completely in the opposite direction and have absolutely no screening or partitioning either, that's not really a productive work scenario to have, particularly where you've got a whole load of workstations that are in very close proximity. The other thing is acoustic boots. They've been around for quite some time. Interestingly enough, over the past 2 or 3 years, they've absolutely exploded. There are dozens and dozens of different acoustic booths on the market. The more fully enclosed your booth is, the better it is at blocking sound. That means you can have it much closer to your workstation. So the idea being you can have them in close enough proximity that if you're sat at the workstation, your phone rings, you can get up from your desk, get into the booth, and answer the phone without distracting anyone. Just one important thing to note, and this is not coming from me, but from the acoustic engineers who developed the testing methodology to determine how well these acoustic booths actually block sound. One of the main things that they identified, the biggest structural feature that determines how well the booth is actually going to be able to block sound is whether it has its own bass. So you'll notice some booths don't have their own floor plate. They sit on the existing floor, and then other booths actually come with their own bass. It can make a very big difference in terms of how well they perform. The other consideration is also the seal that you have between the door and the frame itself. All right, so still on the topic of speech privacy, that's really where acoustic furniture performs particularly well. As the name entails, it's furniture items that are designed to absorb sound waves. Like I said, the majority of the noise is produced by people talking and interacting. Generally, those conversations and those interactions will happen in your collaborative and your breakout spaces. So it makes a lot of sense if you can populate those areas with furniture that's able to absorb sound. Similar to what we were saying in terms of the desk-based screen, you've got your absorption right there, closer to the source of the sound. You're able to capture much more of that acoustic energy before it's able to spread. All right, I think we've got about 3 or 4 minutes left, so I'm just going to quickly shoot through the last couple of slides. Speech clarity, I don't think I need to mention anything on that. That's really just pertains to meeting rooms and boardrooms. As I said, it's all about call quality, not having too much reverberation. Last time I'll say this, the app that we have is designed specifically for those types of spaces, meeting rooms, boardrooms, and small enclosed offices. Right, so in summary, there's lots of different product categories: wall mounted, ceiling suspended, acoustic lighting, acoustic furniture, screening and partitioning, acoustic booths. Some work better than others. We always advise that you start with an actual description of the issue. That can give you a good idea in terms of which product categories would be a good first choice. So as I said, when it comes to excessive noise, in most cases, that's a result of too much reverberation. You need to introduce a certain amount of absorption. Generally, if you're going to do ceiling suspended or freestanding items, you're going to get more absorption. Anything that is occupying free space is actually able to absorb sound from multiple different directions. So generally, ceiling suspended, freestanding will provide more absorption than wall-mounted products, because the wall-mounted products only have one exposed surface, and often they are in the perimeter of the room, so much further away from the sound. Speech privacy, reducing conversational distractions, screening, partitioning, and acoustic boothing. You really want to prevent there being a direct line of sight between different parts of the office, and particularly between different workstations. Right, and then the speech clarities, the meeting rooms, those can be a bit challenging. Where do you put your acoustic material in? A lot of meeting rooms do not have a lot of floor space. We often see a lot of glass and a lot of boundary glass windows. That means you don't really have space to mount items on the wall, and you don't necessarily want to overpopulate the ceiling. So acoustic lighting, very good solution for meeting rooms. You need to have your lighting within a certain proximity of the tabletop in order to ensure you have your 500 lux levels. So it makes sense to turn that item into a sound absorber as well, purely because the proximity is also very important. If you do have space in the corners of your meeting room, that's generally what we would characterize as dead space. It's not serving any purpose. That's a good location to put any freestanding items. Remember, the thicker, the bigger the item is, the more absorption it will provide, the less of them you'll actually need to introduce into a space. And then just lastly, the space planning. So like I said, how you lay your office out, which departments you put adjacent to each other. The acoustic furniture, by its very nature, is generally quite large. Larger the item is, more exposed surface area, more absorption. If you can introduce a lot of acoustic furniture items into a space, it goes a long way in terms of reaching your acoustic quota, in terms of the amount of absorption. That means it can reduce the amount of panels that you need to put on the walls of the ceiling. Obviously, also bearing in mind acoustic furniture, acoustic lighting, those are dual function items. You can often draw from your lighting budget, from your furniture budget, without having to have a dedicated acoustics budget as well. So those two particular product categories represent very good value for money. Right, so I've probably got 2 or 3 minutes to go through this last section. I'll do it as quickly as I can. When it comes to the acoustic performance of products, they should always be certified and verified by an independent third-party acoustic laboratory report. So we use a company called Puurts. They're based in the Netherlands. They test all of our products, and that is the information that we include in the PSS sheet. Very important that you actually properly scrutinize the claims of different suppliers. They should be able to provide you with an acoustic test report to substantiate the claims that they're making about performance of their products. It's surprisingly difficult to find any of this information on the majority of manufacturers or suppliers' websites. We have all of it available, free to download on each of the product pages. One thing to bear in mind, probably the most important thing, is that there's different testing methodologies for wall-mounted products versus products that are suspended from the ceiling or freestanding. That acoustic data is still shown in a graph, but a lot of people don't realize it's actually two completely different and distinct graphs. They're not actually conveying the same information. So just to illustrate this, we've got the same acoustic product. It can be wall-mounted or it can be suspended from the ceiling. When it's flush wall-mounted, it's tested lying flat on the ground in the reverberation chamber. The calculations that they use to determine the absorption, that's all done in accordance with one international ISO standard. So it doesn't matter which acoustic laboratory it is, they all adhere to the same testing protocols. So if it's flush wall mounted, it has an absorption coefficient graph. You know it's an absorption coefficient graph when the highest value on the y-axis is 1. Very important to understand, this graph is actually not quantifying the amount of absorption. It's not telling you how much. It's actually telling you how well a product absorbs. And I use the phrase how well because this graph is a reflection of a percentage. So that 1 equates to 100%. So it's effectively saying from 500 hertz up to 4,000 hertz, it will absorb 100% of sound waves. If you take that item, you suspend it from the ceiling, it's now able to absorb sound on the bottom. It's also able to absorb sound on the top in terms of any sound waves that would be rebounding off. Even though it's exactly the same, simply because it's installed in a different manner, it needs to be tested in a different way. And that yields a graph that's called your equivalent sound absorption area in square meters per an object. It's a sentence with far too many syllables. It's easier to refer to it as a Sabin graph because that's what it's showing. This graph is actually quantifying the amount of absorption. It's telling you how many Sabins of absorption an item is providing. Very, very important to understand, and this is the last point I'll make. It is the last slide, so we'll still have 5 minutes or more for questions. The Nrc value, that is a value that can only be determined from the absorption coefficient graph. And with the very rare exception of acoustic baffles, the only products that will have an absorption coefficient graph are flush wall mounted or flush ceiling mounted products. And as I said, that really just comes down to how they are tested. So your Nrc is effectively an average of your absorption from 250 to 2000 hertz. You take those 4 values together, you divide by 4, that gives you your Nrc. Just like the absorption coefficient graph, that is a reflection of a percentage. 0.9 is an average of 90% absorption. As I said, the moment that item comes off the wall, this information is no longer relevant and it no longer has an Nrc value. So very important when you're making comparisons, make sure that you're comparing the correct set of graphs. And like I said, if it's ceiling suspended or freestanding, the correct graph for that product to have is the Sabin graph, the equivalent sound absorption area in square meters per an object. Hence me saying, always ask where possible for the acoustic test reports so you can confirm that the data is actually correct. All right, so with that, I've rushed through most of the presentation. I just want to see there are a couple of questions that we have. I just want to start at the top. Oh, there's Trisha. Trisha has asked me to just to mention, in case we get a chance, if any of you are interested in any of the items that you've seen, our Vancouver reps are Objective Space, Peter and Miyoko Cole. So you could reach out to them. Right. I can see there's Danny just saying, please send your questions in the chat. Okay. Julie is asking, what is the name of the app? The app is called the Buzzi Space RT60 app. We're actually in the process of upgrading the app. The latest version will be going live in about 2 to 3 weeks, possibly 4 weeks. We just had to tweak the app a bit to make it more user-friendly. There's two functions that app serves. The first part is diagnostic, so it'll allow you to measure the reverberation time in a space. It'll ask you to enter the volumetric size of your room, so length times width times height. Once you've entered that data, the app will tell you what your ideal reverberation time should be. So after you've tested the space, you'll see where your reverb is. It'll tell you where it should be. That's generally indicated by 2 horizontal lines. So that allows you to see whether you've got too much reverberation. The second part of the app is prescriptive. So it'll actually allow you to simulate the impact of different acoustic products in the space. So you can add...
And Richard really just messaged back that the app is not available right now. Could be a geographical, or maybe it is to your point that it's being refreshed or renewed.
It's only available on the Apple Store.
Yeah, I looked it up too.
I was actually in talks with the developer this morning about the app, and he was asking if you can go ahead and delete the old app in preparation for loading the new one. So that could be why it's missing. But just keep that name in mind, and as I said, in the next week or two, I can see it's also disappeared now as well. Yeah. So he's removed the old app, and the new one should be loaded in the next week or so.
We have a time for one more question. I think the next one that you see is probably the most, because the second one was actually already answered in your presentation. But the question about what changes are we seeing in the workplace, and how has the strategy for your recommendations regarding acoustics changed?
Oh, I don't see that question. Where is it?
Oh, Danny sent it to me directly.
Okay, sorry. Say that again, Gianpaolo.
So with the changes we're seeing in the workplace, how has your strategy, your acoustic strategy changed, and your recommendations changed? You kind of mentioned earlier more openness. So what are you seeing as kind of big changes?
Yeah, it's interesting because obviously we take a solutions-based approach. So no company is just going to fabricate products and then try and advertise them on the hope that the people are going to buy them. So obviously there's been a massive mix-up over the past 2 years in terms of the way people are working. The general feedback we have from clients and from dealers is that a lot of people are pursuing a hybrid model of work, where you spend 2 or 3 days at home and then the remainder of the week in the office. People are finding generally they prefer to do their focus work at home. And that means that a lot of companies are reducing the amount of individual workstations that they have. They're moving away from dedicated workstations to hot desking. That frees up a lot of space. So generally, we're finding that they're trying to create a little bit more of an agile and dynamic workspace where you've got more flexibility. Their screening and partitioning that's mobile becomes quite relevant. Acoustic booths that are mobile as well, a very good alternative to meeting rooms. So ours are on casters, so you can move them around. The theme for the company for the past year has actually been hubs for togetherness. So creating settings and enclosures where people can gather, collaborate, and interact without necessarily disturbing and distracting other people. How does that manifest itself in terms of particular products? Like I said, acoustic screening and acoustic furniture. The acoustic booths have become incredibly popular. We probably only have a very small percentage of the market share, but we've seen a significant upturn in the amount of sales. So, but a lot of it's a difficult question to ask. A lot of the time we prefer to consult with clients or dealers or specifiers on a project-to-project basis. Acoustic solutions is not really something that you would want to sell off of a catalog like you might do with furniture or desking.
Yeah.
A lot of the time we need to understand, what is the client's hierarchy of priorities? What is their budget? What are they hoping to achieve? What design limitations are there in the space? And through that conversation and the collaboration, you're able to sculpt a solution that's going to be well suited to that space. I know we're running out of time, so I'll just finish with this. There's always an inherent degree of compromise that's at play. There's budget limitations. There's certain items that maybe don't, decoratively suit the space. So every single project is very specific in terms of its outcomes.
Well, thank you so much, Richard. I actually had a bunch of questions written down, but during your presentation, you actually answered them. So you covered a lot of ground. So I want to thank you. This was really great. I also want to thank everybody for joining us today. We'll be sending out a survey today, and I'd love to get your feedback and also hear from you what kind of topics you would like us to discuss in future events. Just as a reminder, so next month we will have our next CEU presentation or webinar on May 12th called Healthy Materials. And you can also sign up for that at chaseoffice.ca/events. If anyone here is interested in finding out more about acoustics, about Buzzi Space, they can always connect with someone at the team at Chase. We'd be more than happy to help out, get Buzzi Space involved, and the reps from Objective Space. So we would welcome, any questions. Love to help you out.
Perfect.
All right.
Thanks, everyone.
All right. You have a good
Thank
evening.
you very much, Richard.
All right. Only a pleasure.
Thanks, everyone.
Cheers.
Thank
Bye.
you. Bye.